Often, when working with data frames, we need to work with data from multiple frames. A common practice is to merge data we want from two frames into a single frame and execute operations on the new frame. If you're familiar with database management systems, this is very similar to a join operation. In this video, we will review how to do this in Pandas. By the end of this video, you should be able to explain that data is usually distributed across different locations and tables, combine data from distinct data frames to obtain a big picture, and distinguish among different ways to combine data sets. For this video, we will use the two data frames given here as examples. The left data frame has two key columns, key 1 and key 2, and additional two columns for city and username. The right data frame has the same two key columns and additional two columns for hire date and profession. The concat function in Pandas can be used to stack data frames and create a new data frame out of them. Here we see the data frame called left being concatenated with itself. The index for the resulting data frame will have the raw indexes from the original tables preserved. If the two data frames given to the concat function have columns that are separate, the resulting data frame will have the columns from both frames represented. In that case, some of the cells for the columns that didn't exist in the original data frames will end up having NaN or missing values, as they will be missing in the first data frame we merged into this larger data frame. Instead of having extra rows with missing numbers, we could also try an inner join. Inner join is a useful operation for merging data as it combines the column values of two data frames into a new data frame, just like we see here. Notice the way to do this is to specify to concat that the join type is inner. In the previous slide, the concatenated data frames were stacked vertically. Here, they are placed next to each other horizontally using the indices 0, 1, 2, and 3. In the horizontal stacking, unfortunately, this isn't a perfect merge for our data either, as the key columns have been duplicated when they were merged into the new data frame separately. An alternative to concat is append. We can also use the append function to append a data frame to any other data frame. It behaves similarly to the concat function, but it is a function of the data frame itself. So we'll say left append and then give it another data frame. Like our first use of concat, we've got those many empty cells again here. The operation, which will give us a true combination of these two frames, is called merge. The benefit of using the merge operation is that it can eliminate the duplicate columns between the data frames it joins. So it's behaving very much like concat using inner join. It just strips out those duplicate columns we had. Although all these methods have utility depending on the situation, I find myself using merge fairly often, as I'm often trying to combine data from multiple different sources, which all share the same keys. In summary, data in the form of tables benefits from both clean and simple joining and merging operations, similar to relational database operations. Pandas provides support for these database-like operations through its native data frame functions, making it easier to integrate data from a variety of sources for analytics on the merged datasets. So now let's start our live coding session to see some of this functionality. Please go to the merge data frames part of your notebook. And let's remember what the columns are in the tags and movies data frames in our notebook. So here we see that both data frames have movie ID as one of the columns. So we can use this movie ID column to do an inner merge on these two data frames. So what we'll do is we'll say movies.merge tags on movie ID, do a inner join. So let's run this. Notice how we merged both the tag data and the movies data all into one frame. So we are merging movies with tags on the movie ID column using an inner join. Notice the link we provided here, because there are a number of useful examples on merging at this site, and I really encourage you to go there on your own and exploring more of these merges. Now let's try to bring everything we learned so far together. In the first line here, we group all the ratings group by, based on the movie ID column. We chose as index to be false, so new sequential indices for rows will be generated. And in the second line, since we don't or won't be using the user ID column, I'm just deleting user ID. And in the third line here, printing, again, using the head function, the top 5 rows. Let's run this. We see that we grouped by movies ID all the ratings. But since as index was false, a new index from 0 to 4 or 0 to n was generated. If I actually made the index true, you would see the difference here. If you run this, movie ID will be the index. So let's switch back to false here and run this, and we'll have our average ratings frame, a new frame. This is great. So we have average ratings now for each movie. We can now merge these average ratings into with the movies table. So we are using the average ratings. We are calling it box office. Movies merge, instead of tags, now we are giving the new frame we generated, average ratings frame, which also has a movie ID, just like movies data frame had. And we are doing an inner merge. And then we get the last 5 rows just to check. Here we see this many new rows are in this merged box office data frame, the one that we called box office. And we have our movie IDs, title, genres, and the ratings. The rating comes from our average rating data frame that we created and we merged into the movies database. We can now use what we have learned on applying filters. We'll start by setting up a filter for those which are highly rated. As we did before, our filter name is called isHighlyRated. And from this box office data frame, we are selecting the rating column that is greater than or equal to 4.0. And let's get the bottom 5 in that new data frame. Next, we'll set up a filter for those movies which have the genre of comedy. So it's the same exact filter we've done for animation before, but this time we call it isComedy. We select all the genres, all the rows with genres that contain comedy. And let's print the first 5 here from that box office. We'll see all the comedy movies here selected. We can also apply both filters at the same time. So we are looking for comedy movies with high ratings. Maybe we want to watch comedy movies tonight and we want to find those. It's very useful. We can apply both filters using the AND operator here, a logical operator, to get back movies which are both rated 4 or higher, and those are which are comedies. So when we have that, we'll see that we printed the bottom 5 of that list. By using merging along with some of these skills from prior videos, we can see that it's very powerful when we combine these features. Next, we'll review some of the more frequently used string operations, including the contains function from the string object, which we've already seen so far.